These satellite images show an often unseen phenomena that occurs in our atmosphere. The ripples that you can see here are called atmospheric gravity waves, and these disturbances occur when air is pushed upward, followed by gravity pulling the air back down again. This push and pull happens over and over, creating the wave.
And they are generated usually by sources in the troposphere, like thunderstorm, hurricane, or wind blowing over a mountain, and they can propagate in the atmosphere. They can go very high and very far from their source.
And as they move through the atmosphere, both vertically and horizontally, they release energy, which can then have an impact on near-Earth space weather and our satellite systems. And while they've been studied before, little is known about smaller-scaled atmospheric waves.
We haven't had a chance to get a measure of the smaller scale waves and the impact that they carry. We know the larger scale waves do carry lots of energy and momentum, but we know their occurrences and things, but we don't know very well the smaller scale waves.
But now, USU and Space Dynamics Laboratory, for the first time together as co-leaders on a NASA mission, will research these atmospheric waves on a global scale by sending this instrument to the International Space Station for at least the next 2 years.
So this instrument, we first built it for ground-based measurement. That was the help with SDL. With this instrument, we will take 4 images every second, and it's going to image about 600 by 600 kilometer field of view, and it's going to tell us the amplitude, the propagation direction, and also we can tell where are the hot spots.
Essentially, this device, called the Advanced Mesospheric Temperature Mapper, or AMTM, is a combination of 4 telescopes that each map a specific region of the infrared spectrum at the Mesopause, the border between the mesosphere and thermosphere, where this airglow layer begins.
We can image the mesopause in the infrared and watch these gravity waves come through that region and know how much is propagating upward into the space weather region, what their velocity is, and then calculate how much momentum and energy they're depositing up in the upper atmosphere.
And by studying this region, it will help our global understanding of the impact of atmospheric waves as they move through the atmosphere and out into space.
Atmospheric gravity waves have a critical importance in connecting Earth's weather system to the space weather system. We think of this as one of, if not the missing link in our understanding of how our terrestrial weather system actually impacts the space environment.